folks, and welcome back to the third part in my series of upgrading the TRS-80 Model 2. Now this last one is more substantial because you can upgrade the entire processing system and turn the Model 2 into a Model 16. And that upgrade was called the Enhanced Model 2. This is the upgrade version of the 6800 processor board. This is the one that goes into a Model 2 that makes it a Model 16. Notice this cutout, because this board is so long, that the support bar that holds all the boards into the bus bar has to be able to go through here, so they had to make a cutout for it. So it was a little oversized, but they made it work. This is a two-board upgrade. You have the processor board and you have a memory board. And I got the memory board. This is the proper memory board for the upgrade for the Model 2. This is a 128 or 512K board. It has 4 banks for memory chips. I found out that these two and these two stay empty. These are for parity chips if you want to put them in, but you don't need them. These 4 stay empty. And I took a look. There's only 5 chips in here. So I took a look and found out that the number is for an Intel 4164. It's funny, it's got an Intel chip in there. It's kind of interesting. I've never seen an Intel chip in a Tandy product. But so this takes 4164s. I double checked on the schematic, and I'm going to borrow some. I've got on some dead boards. Try to fill out 2 of the banks. You put them in, you fill them out like this, either these 2 or these 2, and then a full set if you want to for 512. But I'm going to check on this. It looks like there's places for jumpers, but there's only one here. But I'm going to check all that. Here's a set of switches. I got to see if that's right. And before I try all this out. So let's get to it. Okay, first thing I checked was notes and jumpers for Tandy computer products. Here is the board that we're talking about. As a matter of fact, you can click on this and it shows you, see it's got the cutout there. So we're looking at the right board. And I've already checked the CPU board for these items. All of these are already hardwired into the board, every one of these. So I don't even have to worry about jumpers. It's set exactly the way they're saying to do. Now here's the information for the memory board jumpers. When I was telling you the size of the board, I got it wrong. It's 128 to 256, not 512. But other than that, you've got jumpers 1, 2, 3, 4, and position 2, switch 1 is on. So we're talking, let's see, E13 to E14, E15 to 16, 17 to 18, 11 to 12, and position number 2 is switch 1 on. So let's check that. Okay, I took a look at the board, checked the numbers, and those first 3 jumpers, let's zoom in, are down here. So, see if I can get my big fingers in here. 13 to 14. There. 15 to 16. There. 17 to 18. There. And then they said one more, and that is actually already here. See if I can get you to see that one right there. 11 to 12. Although there's pins up here at the top of the board, they apparently do not have jumpers. They don't say any conditions about the pins. Oh, and the switch up here, only number 2 should be on, and that's what we've got. If you add another board, which you're capable of doing, is you change the switches to let it know you've got other boards to pay attention to. Other than that, there are no changes. These stay on exactly the way they are, no matter what's going on. So there's all the jumpers. So let me fill in some memory, and then we'll work on those cables. Now, I've got a bunch of memory here. They're all 4164s. Yes, I know they're different ones, but I've ordered enough to fill all 4 banks with some for some new replacements. But while waiting for that memory, I'm going to put these in and see what we can do. For those of you who do not do Tandy, you'll notice these 8040665s. Notice they don't say 4164, but they say Motorola. You're wondering, well, how come it doesn't say Motorola 4164? And that's because these were chips especially made with a joint venture between Tandy and Motorola. So these are chips made just for them, and they were used in many computers. So there we go. We've got 2 full banks. The parity chips stay empty. I got the jumpers correct. The switch is set. So cables are next. Okay, here's what we've got. For the 50 pin, actually what I did was I already had some that were made, but they were really long. They happened to have the right jacks at each end, had the right connector heads, but they were really long. Now, this thing needs to have the shortest cables possible. These boards should sit side by side and have the shortest cable possible that isn't straining. So I basically cut them and put a new end on one side. So here's for the 50 pin. You got the card edge connector and the pin header right there. And here's the 34 pin. Same thing. Very simple, straight through, and nice and short. So let's open the computer, put these in, and see what happens. Okay, let's see what happens. Now, I've got the diagnostic disc in. This disc has the capability of testing a Model 2 and a Model 16. So let's let it boot up. I would assume it would still say 64K simply because the Model 2 boards are the ones that are running right now. And here's our diagnostic menu. Notice one is the 6800 diagnostics with basically the Model 2 board in control, and the second one is the 6800 diagnostics with the new CPU board in control of those. So let's try out the ones with the board in control that we know works. Comprehensive, that's the whole spiel. And that's not a good result. Error 4. It didn't even look like it tried. Let's reset it. Try a different one. The comprehensive means it's going to run all of them. Maybe it didn't like the first one. Let's pick, I don't know, something further down the line. Okay, it goes to that test. Let's do one pass. And it's not doing anything. Okay, just to let you know, the time between what I just said and now has been a day and a half. I was attempting to video different sections of me trying out things, but since I got nowhere, I've decided to wait till now. I tell you, when I get to a point where I'm stuck and in an impasse about how to fix something, because I just can't see anything wrong, I just stare at it. Something will become visible that wasn't before. And you know what? That's exactly what happened. Now, one thing I do is I've also had pictures of this board. So here's the exact board. Notice the jumpers, the switches in two, you got the jumper here, no jumpers up there. Of course, this is a full board, but these are empty, all four of these are. There's just nothing that caught my eye until, now do you see it? Because it took me a long time. Maybe it takes you only seconds. Because there's a difference. See this chip on the end? This one that looks different? Look at my board. It's not there. Now, at first, the reason I never noticed it is because take a look at the pins. They all look like there's never been a chip there. They've got solder filled in the holes, and that's usually what happens on a soldered board when an area that would go to have a chip but doesn't, when they solder the board, those holes fill up, and that's just normal. There was never anything there. But I took a closer look, and you know what? Not all those holes look that way. It looks like there was something here and a few holes, and you go to the back and look really close to where that is. There's pins there. There was something there. There was a chip there, and it's been cut off. Now that says it is U13. So let's look at the schematic and see if we can find U13. And I found it. U13. It's a TTL DL200. That's a delay line chip.
Now, delay line chips are used to help compensate for variations in signal propagation times between different signal paths.
Now, this is a 200 nanosecond delay line. Although it took me quite a while, I did manage to find a seller for this exact chip. It's not the same brand. Actually, it may be the same brand. I think it's a DL5005. But the important part is to make sure it's a 200. All right, while we're waiting on the delay line, I did with memory hour. Let's go ahead and put that in. Let's take it out. Probably speed this up, I'm sure. There. Sorry, my hands are dirty. Whoa. Sorry, my hands are dirty. I didn't realize I just came in from pulling weeds when I got these in the mail. So, here we are, fully populated, ready for our last piece before we test it. I'm going to check on it, make sure there isn't anything bent, and then we're waiting for 2 days to get that final chip. Okay, finally got our delay line chips. DS1005, and the 200 is the number that tells you that we've got the right one. Now, these happen to have all their legs, so I'm going to have to snip off the ones that I don't use. And if you're wondering why I buy two, I never buy one of anything. For one thing, I could screw this up in seconds and then have to wait another week for another one. And you never know, when you buy one of something, you never know when you might have to use one again. So, I think I'm going to make this simple and keeps me from making a mistake. The pins that aren't used don't go anywhere on the board. They're just there. So I'm going to take the solder out of all of the holes and just put the entire chip in there. All right, all clear. So now we put in our chip, we face it the right way. All right, now we're finally going to put this in the system and see if it does any better than the last time. Okay, between the last clip that you just saw and right now has been over a year, because I actually had the video done about the 68,000 upgrade, and then I realized while I was editing that I never filmed it coming up and working, which it had done. I didn't film it. So I just, well, okay, I'll go back, I'll film it, and I turned on the computer, and guess what? Those boards never worked again. And on and off in the past year and a quarter, I've been trying to think of anything that was wrong. The memory on the memory board, of course, having two boards to work with doubles the problem of tracking it down. But actually, the biggest problem was moving here. That took up most of my time. So I finally got the stuff out and examined. I used this. This goes into the Model 2 in the card cage. It allows you to put a board on top so it can stick up out of the card cage and you can access all the parts so you can get some readings and some notations and some signals. And so I started with the basics. The board is getting all of its voltages correct. When you power it up, these chips get very hot, but that's normal because these are transceivers, and transceivers get very hot. But other than that, everything was getting the right voltage on the board. I saw nothing wrong. Next step would have been what? The clock signal. Check the clock signal on the microprocessor, and guess what? I didn't see anything. There was nothing. So I pulled the board out, and I want to show you. I'll show you the circuit up in the corner of the area that we're working on. Basically, this is a very simple part of the circuit. You put the crystal in, R15 and R14 is a voltage divider, which puts about 3.5 volts at the pin of the crystal, and it should simply work. But watch the meter. Let me lean in the way first. See? Now that is the output of the crystal. Notice this is at 500 millivolts, so this is basically this line. Every time I touch it, the crystal's getting 3.5 volts, but there's no signal there. There's nothing there. Bad crystal. Okay, finally got a replacement crystal, so let's take out the old one and pray that I might be right on this. And the legs are perfect. And just push it past. Well, I'm going to bend it because the case is way too close to touching. Excuse me, sorry about that. The case is way too close to touching that resistor, so no harm, no foul. Then I clip those off and test it. Okay, I've got the power supply just below 5 volts. It's in here. Put power to top of R16. Excuse my head, just don't want to hit something else. Look at what we got. We now have a clock signal, and it's at 24 megahertz, pretty much on the nose. Let's put the board back in the system and see if it gets a clock signal. Okay, here's the big test. See if we got a clock signal on the CPU. We've got the scope connected. And carefully tie it off so I won't touch anything else. Dudes, we got a clock signal on the chip, which we did not have before. And if you'll notice, frequency is, I believe it's 6 megahertz. It should be correct. Let's put the boards back in and see what happens. Okay, normally selections 1 and 2 to test the 68,000 boards would normally lock up when it starts the test. So let's see what happens this time. It's working. It wouldn't even start at this point. It would lock up. So let's let it run through all the tests and see how it checks out. Then we'll try the other one.
Alright, that's awesome to see. Every single test has passed. Now let's go to the other set of tests for the 6800 board directly and see how those go.
Oh, I failed an interrupt test, but I've seen that interrupt fail before. It doesn't seem to affect any software I've had. It does the same thing when I'm testing the Z80. Okay, last thing to test would be to see if we can boot up TRS-80 version 4. It's either 1 or 2, but it would only load with the upgrade boards in it. It wouldn't work in a standard Model 2, so let's see what happens. That's it. Everything works. Hey, is 18 months too long to work on something? Not if you finally get it right. Well, I'm happy you were here with me for this very long repair video, at least for me. Hopefully it's a little shorter for you. And hey, be with me next time. I'll see you.